Earth is full of important resources like minerals and ores which are a key to our industrial and economic development. Manufacturing industries that use minerals as raw material are called mineral-based industries. In this module, we will discuss in detail about the iron and steel industry, aluminium smelting, and chemical industry with a special emphasis on petrochemicals. All industries need machines, and iron and steel are basic materials used to manufacture machines. Thus, the iron and steel industry is the basic industry on which all other industries depend. In fact, the production and per capita consumption of steel is a measure of a country's economic development. Steel is used as a construction material and in the manufacture of a large number of medical, defense, communication, and consumer goods. The main raw materials used in the iron and steel industry are iron ore, coal, and limestone. Since the raw materials and finished products of iron and steel industries are quite bulky, these industries must be located near the mining areas of the required minerals and must be connected by a good transport network. The production of iron begins by mixing 4 parts of iron ore with 2 parts of cooking coal and 1 part of limestone, and adding this mixture to the blast furnace where iron gets melted and converted into steel. A small portion of manganese is also added to harden the steel. Molten iron from the blast furnace is poured into mold called pigs to produce pig iron. Pig iron is melted, purified, and alloyed with metals like manganese, nickel, and chromium to produce steel. Molten steel is rolled, pressed, cast, and shaped into ingots of the desired shape and size. This steel is supplied to other manufacturing industries. With a production capacity of 72.2 million tons of steel, India is the 4th largest producer of crude steel and the largest producer of sponge iron in the world. India is also a leading exporter of steel in the world. However, the per capita consumption of steel in India is only 49 kilograms as compared to China, where it is over 182 kilograms. The reason for this could be that India took noticeable steps towards industrialization after a long period of stagnation. Back in the 1950s, India and China were almost neck to neck in their steel production. However, today, China has become the world's largest producer and consumer of steel, leaving India far behind. There are 10 primary integrated steel plants in India, as shown on the map. These integrated plants handle all stages of steel production, from procurement of basic raw material to producing finished rolled and shaped steel. Besides the 10 primary integrated steel plants, India has many mini steel plants that produce customized alloy steel using scrap iron or sponge iron as raw material. If you look at the location of steel plants in India, again, you will find that most of them are located in the Chota Nagpur Plateau region. This is because of the availability of inexpensive, high-grade raw material and abundant cheap labor in the region. There is a vast potential for the growth of the iron and steel industry in India. The main challenges faced by the industry in realizing its full potential are limited supply of expensive coking coal, erratic power supply, low output of labor, and poor infrastructure. Despite all the challenges, the future of India's iron and steel industry is bright due to India's liberalization policy and foreign direct investment in the industry. The industry needs to focus on research and development efforts to become a competitive steel manufacturing force in the world market. Let's look at aluminium now. Aluminium is a lightweight, corrosion-resistant metal with excellent malleability and ductility. Aluminium is a good conductor of heat and electricity and can be alloyed with other metals to make it stronger. Aluminium is used in making a large number of items, from wires and cables to kitchen utensils to aircraft. Aluminium is increasingly being used as a substitute for steel, copper, zinc, and lead in several industries. The process of deriving metallic aluminium from its ore is called aluminium smelting. After iron and steel, aluminium smelting is the second most important metallurgical industry in India. Bauxite, a dark reddish mineral, is the chief ore of aluminium. Bauxite needs to be converted into a fine salt-like white powder called alumina before metallic aluminium can be extracted from it. The manufacturing process of aluminium begins at an alumina refinery. Here, bauxite is crushed and alumina is obtained using certain chemicals. 4 to 6 tons of bauxite yield around 2 tons of alumina. Alumina is transported to an aluminium smelting plant along with 2 more raw materials: calcinated petroleum coke and pitch from a colliery. At the smelting plant, aluminium is derived from alumina through an electrolytic process. 2 tons of alumina yields around 1 ton of aluminium. Processing 1 ton of alumina uses 18,600 kilowatt-hours of electricity. India has 8 aluminium smelting plants located in Orissa, West Bengal, Uttar Pradesh, Tamil Nadu, Kerala, Chhattisgarh, and Maharashtra. By 2009, the annual production of aluminium in India was 15.29 lakh million tons. Since the production of aluminium requires the transport of bulky raw materials and large amounts of electricity, a short supply of power and good transport connectivity are the main criteria for the location of an aluminium smelting plant. The Indian chemical industry is the 3rd largest in Asia and the 12th largest in the world. The Indian chemical industry contributes 3% to our national GDP. There are a large number of big and small manufacturing units engaged in the production of inorganic and organic chemicals all over India. The main inorganic chemicals produced in India include sulphuric acid, nitric acid, alkalis, soda ash and caustic soda. The chemical industry is the largest consumer of its own products. Basic chemicals produced by one company act as raw material for another that produces industrial chemicals. For example, sulphuric acid is used in the production of fertilizers, plastics, synthetic fibers, adhesives, paints and dyes. Similarly, soda ash is used in manufacturing soap, glass, detergents and paper. A major part of organic chemicals is petrochemicals. Petrochemicals are materials derived as the byproducts of petroleum refining. Thus, most organic chemical industries are located near refineries. Petrochemicals are used to manufacture synthetic fibre, synthetic rubber, dyes and paints, fertilizers, adhesives and medicinal drugs.